So the difference between example 1 and example 2 is now we have some variables. So for A, okay, it's also asking where is the expression defined, so we get to practice that some more. Where is it possible? And then we want to expand and simplify it. So first of all, we look in A and we see that we have some square roots. And we know that we can't take square roots of negatives. So we check, will that ever be a problem? Yes, that would be a problem if B were negative. So this one is only defined when B is positive. So first of all, we look at that, say we can't take the square root of a negative, so it's only defined when B is greater than or equal to 0. Then when we expand this, 7 times 3 is 21. 7 times negative 5 is negative 35. Root B plus 6. Whoops. 6 root B, and finally the outside ones, 2 times 5 is negative 10. And B times B will be B squared. Wow. Did this B start to look like a 6? Yeah. There we go. Oh, that's a nicer B. You wrote a 6? Oh, no. Sorry about that. Okay. So now we see that we have some like terms. The middle ones, the root B and the root B, negative 35 root B plus 6 root B. Those combined are going to be negative 29 root B. Still have a 21 out in front here. What can I do with the root B squared? Well, the square root of B squared will just be B. So we get negative 10B. Now, in the first part of this unit, we said sometimes we put absolute values around it when we did the square root of B squared, because a square root is always positive. So sometimes you might be tempted to put absolute values around this, and that would be okay. In this case, you don't have to, because at the beginning we said B was a positive number. Okay. Quick thing. Yeah. Thank you. Oh, good thing. Whew. And at this point, now we have no like terms. We've simplified all of our radicals, so we are done. That's it for that one. We've said where it's defined, and we've simplified it as much as possible. We've expanded it because there's no more brackets. And all three of these are not like terms. They're not like radicals, so they can't be put together. Now for part B here, this one's going to take a little bit of space. We're going to have to, in the first one here, multiply these out. Do you notice that they're conjugates? Do you notice that the first two are conjugates of each other? They're the same numbers, but one is positive, one is negative. And for the second one, I'm going to write it out because squared means multiply by itself. So I'm just going to write it out like that so that when I FOIL, I'm thinking of all my terms. So I'm not tempted just to square this and just square this, because you will be tempted to do that sometimes. And there's a negative in front for subtracting afterwards, which is going to come into play. Okay. This one has a fair bit of complications to it. Now, what I'm going to do when you have something big at the beginning and then big at the end with a subtraction sign in between, I'm going to put a set of brackets here because I'm going to simplify the first thing. And then I'm going to put a big set of brackets here because I'm going to simplify the second thing. And I'm going to keep my minus sign in the middle. Now when I multiply the first ones, I'm going to get 3 times 3, 9 root x squared plus, or sorry, minus. I do the outside. Minus 3 root xy. Inside will be plus 3 root xy. And finally, minus square root of y squared. For the second set, root x times root x will be root x squared plus 5 root xy plus 5 root xy plus 25 root y squared. So we FOIL the first ones, we FOIL the second ones. Now we need to expand, so eventually we want to get rid of all the brackets, but I'm going to simplify each one in its brackets first before we get rid of the brackets. Oh, and we never said where this one was defined, did we? Do you want to do that at the end? Yeah. Okay. So square root of x squared will just be 9x. Can you see that these two are identical, but one is positive and one is negative? That always happens when you have a conjugate. So we're going to have 9x, and then the last thing I have is minus the square root of y squared, which will just be minus y. Simplifying my second set of brackets, square root of x squared will just be x. The two middle ones are like radicals, so I can put them together. And the square root of y squared will just be y. So now I've simplified the second one as much as I can. Now when I want to put these together, we have to be careful because this subtraction sign here that we wrote all the way through means that we're subtracting all of this, which means we're subtracting all of this, which means we're subtracting all of this. And when you're subtracting more than one thing, this negative sign will get distributed to each one. So it's like minus x minus 10 root xy and minus 25y. So I kept my brackets there so I wouldn't forget that in the end this minus sign is going to need to be distributed to each one. Now do I have any like terms? 9x minus x be 8x, negative y minus 25y will be negative 26y. And I have minus 10 root xy. I check, I don't have any more like terms. My radical can't be simplified any further, and I have no like radicals, so I know that I'm done. As far as where was this one defined, if we go back to our original equation here, you can't take the square root of a negative. Does it make sense that x has to be bigger than or equal to 0? And that y has to be bigger than or equal to 0. Otherwise, you would be taking a square root of a negative. And any time that you define them as positive to begin with means that you never have to worry about that absolute value sign when you simplify. Generally speaking, I'm not going to be too picky on when you simplify the square root of x squared that you write it as absolute value of x. So I'm not going to be too picky on that. And while you're simplifying, especially something this big, to add absolute value signs just makes it even more ugly as you're going along. So don't worry too much about that. As far as questions to do after example 2, just number 8 to add to that.